hopefully you are continuing on in this series. This is still activity 2, and this is page 4 for the 7th grade post-course test for advanced 7th grade material. And we're on question number 40. A calculator display shows 9.2E9. Write the number in standard form. So this is in scientific form. So scientific notation, 9.2 times 10 to the 9th. That E, I don't know, you can kind of say that it means an exponent, but that doesn't necessarily lead you to believe that it's 10 to the 9th, but scientific notation, that's how we do it. So we're going to move this decimal point 9 places because there are 9 tens. Each 10 represents 1 decimal place. So we'll write 9.2, and then we'll start moving it. So it's here. It goes 1, 2, 3, 4, 5, 6, 7, 8, 9. And each loop represents a 0 or a 10 when you multiply it by 10. So my number is 920. So we have 1, 2, 3, 4, 5, 6, 7, 8 zeros. 2, 3, 4, 5, 6, 7, 8. And every 3 gets a comma. So that is going to be in standard form. That's written out form. So that is thousand, millions, billion. So that's 9,200,000,000 would be the number. And that's equally as important to know how to read it out. So we have 7.7 times 10 to the negative 5 minus 6.4 times 10 to the negative 5. Since they are the same base, we are able to just subtract these two. Now that is only because we can align the decimal points only because they are the same base to the same exact exponent. That exponent is going to move that decimal around, so that's why it's important. So we can just subtract those, and we would get, in scientific notation, 1.3 times 10 to the negative 5. It is not going to change our answer. It's going to leave it, and this number has to be between 1 and 10. So that's a good question. You only understand this if you write this subtraction part. If you understand scientific notation. Now, multiplying is a totally different one. Multiplying, we're going to take the numbers and we're going to multiply them. So we have 5 times 7, which is 35. Then we're going to multiply the like bases. When we multiply like bases, we are going to add their exponents. Well, you can do... That doesn't look like adding, does it, Mr. Mack? It is, but we're going to add their exponents. So we get 35 times 10 to the negative 6. Now, remember how I said this number needs to be between 1 and 10. It's 35. 35 is not between 1 and 10. So that decimal point is here. I have to move it one place. So this now becomes 3.5. And we had a value of 10. We made a big number small. Where did that bigness go? Well, it has to go here. But notice that 10 is 10 to the first. So I have negative 6 plus 1 is negative 5. So the correct answer would be 3.5 times 10 to the negative 5. Very good question. Really tricky. Really good practice to do this one. All right. These are square roots. Square roots, you don't see the 2. It's invisible. It's understood that it's a square root. And square roots can only cancel with squares. They are inverse of each other, just like if you have an operation, addition, the inverse of addition is subtraction. If the operation is subtraction, the inverse is addition. If your operation is multiplication, the inverse is division. If your operation is division, the inverse is multiplication. And if you're squaring, if you have something squared, the inverse is the square root. And if you have a square root, the inverse would be squaring. Okay, so what's going to get rid? Each of those get rid of each other. So I need to write this as a square. That's the only thing that's going to get rid of a square root. Well, we know that we can write 4 as 2 times 2. And we know that 2 times 2 can be written as 2 squared. And so now we have a square and a square root will cancel each other, and you get 2. So the square root of 4 equals 2, and that's a memorizing one. I think we did that earlier. You should know the perfect squares. Square root of 1, square root of 4, square root of 9, square root of 16, square root of 25, square root of 36, square root of 49, square root of 64, square root of 81, square root of 100, square root of 121, square root of 144. So square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Those are reasonable, which you should know. You should probably know up to 20. But these are all called perfect squares. So when we do radicals, this is a perfect square. Very important for us to know. Perfect. Whoa, that's not how you spell perfect. Oh, yes, it was. Huh. Perfect square. Important to know those. All right. So when we have to solve this, we want to isolate the variable. We want to get x by itself. There are 3 things happening to it. First of all, 39 is being subtracted from it. 4 is being multiplied. And 2 is squaring that variable. So I got to get rid of things being added and subtracted first. So I'm going to get rid of that negative or subtracting 39 by adding 39. That leaves me with 4x squared equals, that is 144. And now we're going to get rid of the multiplication, so we will divide by 4. That leaves us with x squared equals, what's that going to be? That's going to be 36. And now we have to take the square root. It's being squared. What gets rid of a square is a square root. So we're going to take the square root of x squared. And what we do to one side, we have to do to the other. So we're going to take the square root of 36. And whenever we take the square root of a variable being squared, we have to introduce plus minus. Because think about it. Well, let's simplify this out. The square root and the square will cancel, leaving us with x. Square root of 36 is a perfect square, and we get 6, so plus or minus 6. Because if we have a negative 6 times negative 6, that equals a positive 36. As does 6 times 6 equals a positive 36. So when we have a variable being squared, we have to introduce that negative side of it also, that negative distance. So my answer is going to be plus or minus 6. You can write it like this if you want, but high school is going to start introducing this plus or minus. It's a nice, efficient way to represent 2 values. All right, here we have a triangle. It is a right triangle. We have to notice that. And we have 2 legs. These are the legs of the triangle. We call these the legs. And the side opposite the 90-degree angle is called the hypotenuse. So there are 2 important things, legs and hypotenuse. And we're going to use something called Pythagorean theorem. Pythagorean theorem. And Pythagoras devised and understood that there was a relationship for all right triangles. He said that the sum of the squares of the legs should equal the square of the hypotenuse. And so leg squared plus the other leg squared should equal the hypotenuse squared. And that theorem actually looks like a squared plus b squared equals c squared. When you have a right triangle, the legs are a and b, and the hypotenuse is c. So in this example, we have a as our b is going to be 20, and c is going to be 25. So a squared, we can simplify these. 20 squared is 400. 25 squared is 625. Pretty sure of that. 25 squared equals 625. I was correct. And now we're going to isolate, so we will subtract 400. And that leaves us with a squared equals, well, that's 5, that's 2, and that's 225. So I need to take the square root. I got to get rid of that square, so I will take the square root of both sides. And remember that when I introduce the square root of a variable being squared, I have to do plus or minus. The square and the square root will cancel. And that leaves me with a equals plus or minus now 225. So if you went along, you probably notice if you stopped at 12 times 12 is 144, you probably wouldn't have gotten to 15. And I think 15 squared equals 225. And it does. So this is a perfect square. So we get plus or minus 15. Okay, so this is a perfect square. And the perfect square is 15. So my answer is going to be plus or minus 15. Well, what do we know about that? It can't be both of them. It can only be 15. So the answer is 15. Why can't it be negative? Well, because we're talking about a distance here. So this distance cannot be negative inches. And speaking of, I should include inches. So my answer for A is going to be 15 inches. Oh. Okay. Number 46. So find the slant height. We need to know that slant height is really important when we want to find the surface area. Okay. Now in this question, we're still going to use Pythagorean theorem because we see this right triangle within this pyramid. This is I'm assuming is a square pyramid. And so if we have this triangle here, this right triangle, we have a base of 10.2 millimeters. We have a height. This is a slant height. This is the interior height or the height of the object, which is 13.6 millimeters. And we want to find the hypotenuse, or C. So remember, a squared plus b squared equals c squared. So we'll say this is A is 13.6 squared plus 10.2 squared equals c squared. So 13.6 times 13.6. Yes, I could use a calculator, but it's always good to get this practice down. 6 times 6 is 36. 18. 6 times 3 is 18 plus 3 is 21. 6 times 1 is 6 plus 2 is 8. We're going to move over decimal place. 3 times 6 is 18. This time we're going to carry a 1. And 3 times 3 is 9, plus 1 is 10. 3 times 1 is 3 plus 1 is 4. We're going to erase those carries. And now we move another decimal place. So you have 1 times 6, 1 times 3. And let's move all this over. And 1 times 1. Now we're going to add up the columns. That's 6. That's 9. That's 14. That's 8. And that's 1. And we have 2 decimal places. So I'm going to move my decimal point 2 places. So we're going to get 184.96. Let's multiply 10.2 times 10.2. 2 times 2 is 4. 2 times 0 is 0. 2 times 1 is 2. We have 0, 0, 0. Move to the second. That's 2, 0, 1. That's 4. That's 0. That's 4. That's 0, 1. Two decimal places. So we're going to add those. Equals c squared. Let's add those two values up. We're going to align. Now we're going to align 184.96 plus 104.04. That's 10. That's 10. That's 9. That's 8. 289. 289 equals c squared. Let's drag all this. Let's group it. Let's make it smaller. Let's place it down here. And let's take the square root of both sides. So square root plus or minus 289 equals the square root of c squared. Square and a square root cancel. C equals plus or minus 289. Okay, what could that be? 289. Could that be... So it's going to give me 17? Could be 17. Let's check it out. Let's see if it's 17. 289. Let's take the square root equals 17. Mr. Max, good. 17, and the units are millimeters. Now remember, this is plus and minus 17, so the only one that we can use is the positive value because we can't have negative distance. So this slant height, the outside from the top of the object down to the base, perpendicular, is going to be 17 millimeters. That's a good one. Your friend's house is 6.4 miles north and 12 miles west of your bank. How far is your friend's house from your bank? Okay, so you have a bank. Our bank holds money, and it says your friend's house is 6.4 miles north and 12 miles west from your bank. Okay, so it's here. How far is your friend from the bank? So we would draw a line to that. And can I move that? Yes, I can. Good. So we notice that 12 miles and 6.4 miles is going to be the legs of that right triangle. And so we have 12 squared plus 6.4 squared equals my hypotenuse squared. 12 squared I know is 144. 6.4 times 6.4, 4 times 4 is 16. 24, 25. Move a place value, 24. 36, 38. 6, 9, 10, 4, 2 decimal places. So that's 40.96 equals c squared. Let's add those together, and that gives us 184.96 equals c squared. We're going to take the square root. When we take the square root of a variable being squared, we need to include plus or minus. 184.96. I'm going to use the calculator on this one. This one, I don't know. I can't guess that one. So 189.96. We're going to take the square root, and we get, ooh, doesn't even say to round. So before we do that, let's make sure that we did 6.4 squared correctly. That gave us 4096. Let's add 144. We got 184.96, so that number was correct. Let's take the square root. Okay, and we got, oh, I must have typed in the wrong number, 13.6. So plus or minus 13.6 equals C, and we know it can't be the negative value, so 13.6 miles as the crow flies from the bank. Ooh, so remember how a square and a square root, so the operation and the inverse, so if the operation is something squaring, the inverse would be square rooting. Well, what if something was being cubed? Yeah, cube root. And if something was being, if we had the cube root, what's going to get rid of it? A cube. So I'm looking for perfect cubes. So we can separate this division into two separate cubes or radicals. So the cube root of 1 equals 1, and the cube root of 343 was 11? 11 or 21? So notice we have a cube root here. So 343 equals, oh, not even close, 7. Wasn't even close. Now, notice I didn't do plus or minus because it's positive. So cubes or odd exponents, we don't have to worry about plus or minus. Okay? So there's no negative number timesing itself 3 times that's going to give us a positive. It's always going to be negative. So this is the answer, 1/7. So here we're gonna isolate the cube, 256. So how do we get rid of things being multiplied? We can either divide or multiply by the reciprocal. So we're going to double that value. We get x cubed equals 256 times 2, which is 512. 12 carry, 11 carry. Yep. And now we're going to take the cube root. The cube root, we don't have to worry about plus or minus, remember. And we have to write cube in these. It's not understood, so you have to write that. And that is going to give me, these will cancel, x equals, I want to say, what do we want to say? 512. Well, that's is that 8? Is that 8? No, that's too small. 16? No, that's always going to give us a 6. So that's not, I think it's base 2, so let's erase it. 512 and the cube root equals 8. I was right, 8. Okay, so answer is 8. X equals 8. Write each number as a fraction. Okay, so this is a repeating decimal. This is technically equal to ... So what we can do here, and this is a little trick, it's somewhat interesting. So I can take x and I can let it equal this value. And if I multiply it by 10, if I multiply both sides by 10, I get 10x. And if I multiply this by 10, I get 1.66 repeating. And then these are equivalent, if I subtract these, I get 10x minus x, which is 9x. And all of these repeating 6's will cancel with each other if we're subtracting. And then I get 5 here, and I get 1. So it's a nice way of getting rid of that repeating decimal. I'm just subtracting the bottom from the top, and now I get now I get a problem that I can solve. So 9's multiplying x, I can divide it by 9. That leaves me with x equals 1.5 over 9. I can't have a decimal in any fraction as an answer, so I'm going to move that decimal point. I'm going to multiply it by 10, and then I'm going to have to multiply the bottom if I want to keep it equivalent. So that becomes 15 over 90, and now I can simplify this fraction. And 5 goes into that 3 times, 5 goes into this 18 times, and then 3 goes into that. It goes in 1 time, and 3 goes in 18, 6. So we will know that the fraction value of that repeating decimal is 1/6. And we can check it. We can check and see, making sure, why can't I move it? So let's clear. Let's do 1 divided by 6 equals 0.166666. Why does it have a 7 at the end? Because the calculator rounded it, because it can't keep going on the calculator. It does go on forever, but that's a way of converting. Now this one's way easier. It's not repeating, so you take the number, you take the digits, 16 over the place value, that's ones, tenths, hundredths. So that's going to be 100 in the denominator, and we always have to simplify. I'll divide each one by 2. We'll divide by 2 again, and we get 4/25. And we can check 4 divided by 25 should equal 0.16. Good. Totally different number, though. That's why it's a big difference between repeating and non-repeating. And here we go again. So I will use x to represent my repeating decimal, and then I'll multiply it by 10. And if I multiply it by 10, it becomes 8.33 repeating. Let's subtract these 3's. All the repeating 3's cancel. I'm going to have to borrow, and that's going to give me 5.7 equals 9x. 10x minus x gives us 9x, and now we're going to divide by 9, and we get x equals 7.5 over 9. We'll move that decimal. We can't leave that as a fraction. So that equals 75 over 90. We can divide it by 5. So 5 goes into 75. Ooh, how many times is that? No, 75 is 3 times 25, and 25 is, so 5 goes into 75 15 times. And that's going to be 18, and 3 goes into those, 5, 6. So let's check and see. Does 5, 6 equal 0.83? Repeating, 5 divided by 6, 0.83 repeating. Yeah, good. Okay, nice. Love that it's working out. Ooh, now this one's a little bit easier. Notice everything to the right of the decimal is repeating. So there's a trick here. We can take the digits, 19, and we can put it over, not 100, this is tenths, hundredths, not 100, but 99. So 2 numbers repeating, 2 9s. And that cannot be simplified. That is in its lowest terms. So we like that number. But another example would be if we had 0.5 repeating. Well, we put the 5 in the numerator, and only one digit is repeating, so you get 5 9ths. if you have 0.137, all of them repeating, you're going to have, that equals 137. How many things are repeating? 3. So you have 3 9s, and that can't be reduced. Cool. So that's a nice example. Approximate the square root of 74 to the nearest tenth. Plot the number on a number line. Well, okay, so we have square root of 1, square root of 4, square root of, well, let's jump, 64, and square root of 81. So square root of 64 equals 8, square root of 81 equals 9. So notice 74, square root of 74 is in between these. Okay, and how close is it? So we're going to approximate. So if we have between 64 and 81, well, half of that, what's that distance between those? 81 minus 64 is going to give us, what's that, 7? 17 is going to be half. So 64 and 17, not 17, divide that in, sorry. So that's the distance. 17 is the distance between these two. So if I take half of that, so if I divide that by 2, I get 8.5. So if I add 64 plus 8.5, we're going to get 5. We'll get 12, 72.5. So 74, so halfway. So this is more than halfway. So I'm going to say 8.6 would be a good approximate value to the nearest tenth. So we can check that out and do 74, and we can do square root. And what do we get? Oh my goodness, look at that, 8.6. Not bad for some good math here. Okay? So hopefully you saw the logic behind that. Which number is greater, square root of 8 or cube root of 93? All right, well, square root of 8, so we have square root of 8, so we have square root of square root of 4 and square root of 9. So this equals 2, this equals 3, so square root of 8 is going to be approximately, right, 2.8, 2.9. Probably, yeah, 2.8, 2.9. And then if we have the cube root of 93, so what are the cube roots there? So, well, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. So cube root of 93 is going to be between these two. So that's going to be, oh, I don't know. That's going to be 4 and change, 4.5-ish. So we see which number is greater is going to be the cube root of 93 is going to be greater because that's approximately 4.5, where the square root of 8 is 2.8. Approximate the distance. Okay, so when we have, let's draw this out because this will be a good lesson for us. So when we have these, let's make this a little bit bigger. Yikes. Let's move this up a little bit. Let's take these 2 points. So we have -8, 0, -8 on the x, 0 on the y, and then we have -4, 7. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. So we want to know this distance, the distance between the 2 points. And what we can do is we can make a right triangle. We can draw the 2 legs and we create a right triangle. So what is the distance here? What is this leg? This is 1, 2, 3, 4. What is this distance? 7. So we can use Pythagorean theorem. 4 squared plus 7 squared equals c squared. My distance, this is going to be c. So that's 16 plus 49 equals c squared. That's going to give me 565 equals c squared. So we'll take the square root, plus or minus, square root. And we can go, and I forget if it says approximate, to the nearest tenth. Okay, so what we can do is we'll just use a calculator. It's okay to use a calculator. We're going to do 65, and we're going to do the square root. And that equals 0.8.062. So plus or minus 8.062, I think it was. Yep. And if we're going to round to the nearest tenth, I have to look at the hundredths place. This tells me to round it up. And my board went, sorry. Come on. There we go. And so this is going to be approximately 8.1. And does it give units? No. So my answer is going to be 8.1, which is rounded to the nearest tenth. 8.1 units. Good. All right, tell whether a triangle with the side length 65 feet, 72 feet, and 97 feet is a right triangle. Well, one little thing that we need to know is that the longest distance, the longest side is going to always be the hypotenuse. So if we draw this triangle, and we're saying, hey, if it's a right triangle, it must fit Pythagorean theorem, meaning 65 squared plus 72 squared must equal 97 squared. So let's get our calculator out. Should your parent, oh gosh. All right, I got questions, more questions. C, 65 squared equals 4,225 plus 72 squared equals 5,184 equals, let's do 97 squared. That equals 9,409. So we'll add these two side lengths, the two legs, 4,225 plus 5,184 gives us 9,409. And since those two add up, then we know, yes, it is a right triangle. Right triangle. Very, very important skill to know, to test. That was 55. So 56. The volume of a cylindrical container. So we have a cylinder. That looks like that. The volume is 151 cubic centimeters. So this is going to be 151 centimeters cubed because it's volume. And the height is 3 centimeters. Approximate the radius of the container to the nearest hole. So this is going to be the radius. And so we know that volume equals big B times H for any prism or cylinder. Two base figure, volume equals big B. Now B is the base shape. What is the shape of the base? It's a circle. So what is the formula for the area of a circle? Pi r squared times the height of the object. So let's start plugging in these values. We know what the volume is. The volume is 151. We know what pi is, 3.14. We're looking for the radius, but we know the height. So now we want to isolate this. So we want to get rid of this 3 first. Let's divide by 3. And 5, 6, 7, that does not go in nicely. You're not playing nice. Okay, we'll just leave it for the time being. 151 divided by 3 equals 3.14 radius squared. Now, we're not going to divide because that would be weird. So we're going to multiply by the reciprocal. So we'll multiply by the reciprocal, 3.14. So now we have 151 in the numerator. And then we have 3.14 times 3. 3.14 times 3 gives us 9.42 equals radius squared. So now let's simplify this left side. We're going to get an ugly number, 9.42. It's going to be very ugly, but it's okay. This gives us 16.0297 approximately equals r squared. So we're going to take the square root of both sides, 16.0297 equals, plus or minus, equals the square root of r squared. And that's going to give us, so let's take that number and take the square root. And that's going to get, oh, that's nice. That's clean. That's 4.0003 plus or minus is approximately r. So we're going to say that it's approximately, the radius is 4 centimeters. So 4 centimeters is the radius. That's not bad guess. I like how it's pretty clean. Number 57, a cone has a radius. So a cone looks like this. Cone has a radius of 12 meters. So my radius is 12 meters and a height of 31 meters. So it's going to be perpendicular. It makes a right triangle. 31 meters. Approximate the volume of the cone to the nearest tenth. So we again go back to volume equals, but this time this is a single base. So cones and pyramids is 1/3 big B times h. So my base shape, again, is a circle. So we have pi r squared times h. And now we're going to start filling in information. I don't know what the volume is, so we're going to keep this here. I know 1/3. I know what pi is, 3.14. I know what my radius is. It's 12 squared times the height, which is 31. So I have 1/3. I have 3.14 times 144 times 31. Okay, and I'm going to divide. Oh, this 3 is in the denominator. I'm going to cancel this. That 3 can cancel 144. It goes in 48 times. So now I have volume equals 3.14 times 48 times 31. So let's do that math. So 3.14 times 48 times 31 gives me volume of 4,672.32. The unit is meters cubed, and I'm going to round it to the nearest tenth. So I'm going to round it to the nearest tenth. I look here. That tells me to round down. So my volume is going to be 4,672.3, not centimeters, meters cubed. Let's check, make sure, 4,674.7. Oh, maybe they didn't use, maybe they used 22/3. They could. They could have. Doesn't tell me what to use as pi. So let's just, how many more pages I got? Is that the last page? Nope, 2 more. But we'll do it. I got 50 email or text messages coming to me, but we're going to do it real quick. 1/3 times 22/3, which is pi. 22/3 is nope, 22. No, what? 20. What is the approximation of pi? 22 divided by 3 is, 7. What am I thinking? 3.14. What is 22 over 7? 22 divided by 7. There's my pi. No, we're not going to use that technique. Not sure where they rounded. They must have rounded somewhere. Don't know. But I think I'm pretty good. Right? 144 divided by 3 gives me 48. That was correct. Not sure where I made that slight mistake. They just got 0.7. I got 0.3. Let's move on. The volume of a spherical ball. So of a sphere is 36,000 pi cubic meters. Find the radius of the ball. So they want to know what the radius is. And volume of a sphere is 4/3 pi r cubed. So we're looking for pi. We're going to plug in 36,000 in for the volume. 36,000 cubed, or pi, which makes this problem a whole lot easier. Pi equals 4/3 pi r cubed. Let's get rid of the 4/3. We're going to multiply by the reciprocal, 3/4. 3/4. We're going to simplify because 4 goes into 36 9 times with those 3 zeros. And so we get 3 times 9 is 27,000 pi equals this times this cancels. So we have pi r cubed. We're going to divide by pi. Divide by pi gives us 27,000 equals r cubed. We're going to take the cube root of 27,000 plus or minus. No, plus or minus. It's cubed. Only plus or minus on even exponents equals the cube root. We will write cube of r to the third. And let's see what 27,000, the cube root of that is going to be 90? 30. 30 equals the radius. The unit is centimeters. So 30 centimeters equals the radius of a sphere. That was number 58. Last problem. Here we go. This is nice. This is completely different. Whoa, that's not a very healthy 8. So there's lots of different ways we can do this problem. I'm going to do it the most efficient way. There's a couple of efficient ways. But I'm going to get rid of these fractions. Denominators, 2, 2, and 8. I'm going to multiply it by the common denominator. I'm going to balance. I'm going to write an equivalent equation. So I'm going to multiply that 8 by everything. That cancels. You're left with x. That gives me 4 times 5 is 20. 2 cancels with the 8 is 4 times 5 is 20. We'll add 20. And we get x equals 40. How nice and easy is that? Nice way. The other way you could have done is added and gotten 10 halves. So you could have done x over 8 minus 5 halves equals 5 halves. We could have added 5 halves, add 5 halves. We get x over 8 equals 10 halves, or x over 8 equals 5. We can multiply by 8. Multiply by 8, x still equals 40. And that's just one of a multitude of different ways you can do it. All right, that was a long one. Definitely probably your longest page up until this point, page 4. But you're deep into the summer. You're working. You're strengthening your math skills. You're keeping yourself sharp. Nice job.